My name is Zach. I'm from San Francisco, California, and came to speak to you today about cross-platform Android or cross-platform Objective-C development, basically, and also kind of preview some stuff that's happening on the Cocos side as well that we are doing at the moment. So, kind of give you a rundown of what we do. We have kind of one big belief at Apportable that rewriting your code is silly. You shouldn't have to rewrite your code to go to Android and iOS. And having two separate apps is a waste of time because then you're releasing like twice, and you have to QA it twice, and you have twice the code and twice the release schedules. It's silly. So what we're trying to do is solve that without sacrificing anything. And there's plenty of solutions where you can sacrifice. You've got PhoneGap, and you've got Titanium. You've got all these things where you build in a higher level language for every app platform. But what you're doing is then you're also tying yourself to that platform. And if you want to get access to anything native, then you have to wait until that platform exposes it to you. Or then you have to go off venturing, writing plugins or doing something silly. So we ventured into doing is giving you the tools to write native apps for both platforms with Objective-C without any compromises. And so to kind of explain what it is about our company, we came out of Y Combinator in Silicon Valley. We shipped our first app, Osmos. If you guys have ever played Osmos, it was App of the Year in 2011. We basically emailed these guys and were like, do you want to go to Android? And they had no interest at all. And we talked to them and said, well, just give us a chance. It's our first time that we're wanting to experiment with our technology we've been building. And sure enough, they gave us their source code, and we shipped it and blew their minds. We recently raised $2.4 million from Google Ventures, so we're now at Google Ventures, backed startup a couple months ago. And now we secretly actually power hundreds of games on Android, and no one knows because we're not a publisher. But if you actually pop them open, you'd see libobc and libfoundation, and all these things you could find from iOS. But no one really knows that all these things are actually powered, written completely in Objective-C, and no one's writing Java. So what is the Portable SDK exactly? So the Portable SDK compiles your Objective-C source code into a native application that runs on Android. When I say that, it's kind of easier to explain that there is no Java. There is absolutely no Java, and it's probably easier just to say, well, we're not. It is not source code translation. There's no, it doesn't generate Java, and there's no iOS emulator running underneath. We don't try to lie to you and say that you're running on iOS anyway. We do emulate some of the APIs that exist on iOS, and only the more esoteric ones that are used commonly will play like we're on iOS. But for the most part, it's actually native to you in every single way that you could think of. So this is kind of running through. This is normally where I'm going to jump in and actually write some code, but I want to do this a little bit later in this presentation. Because I want to show you something really cool in a minute. All right, so the Portable SDK. It includes pretty much everything that you would expect on iOS. What we've done is anything that Apple is open source, and they've open sourced quite a bit of the low-level bits. libdispatch, libobc, Core Foundation is mostly open source. And then everything that isn't open source, we've either re-implemented or reuse the same open source libraries that Apple's using, like ICU and libc++ and all of those. So we actually have the only implementation of C++11 on Android within our platform because people on iOS expect it and use it. So we get quite a number of users that aren't even using UIKit or doing Objective-C just because we have a better C++ implementation than you would find anywhere on iOS. So to kind of run through it, we use the same clang that you use in Xcode, so same compiler. So you'll get the same warnings, same errors, same everything. We use a slightly newer version of it than Apple does in most cases, so you actually get better warnings and new stuff that come out before Apple even releases anything. And then, so debugging tools, we have the latest GDB technology. We don't have LLDP yet, we're working on it. And then we have our own profiler suite, but most of the time the profiler suite that you have with Apple, you profile for an Apple device and you tune your app, it's going to carry over because what we try to do is give you the same expectations and time constraints that your app should run in. But we do provide our own tool set that lets you figure out the minor issues that you'll find on Android specifically. And then, so we do support many of the third-party libraries, and this is one of the things that we do is kind of are one of our paid products. We do have like this free version of our product, and you can use it, you can ship apps with it, but if you're trying to come from iOS and you already have something written and you want it done really quickly, we actually have a bunch of these implementations of common third-party libraries. If it's a third-party library that's completely open source, you can just compile it, it runs. But if it's not an open source library like Flurry or AddMob or Chartboost, there's usually a Java implementation. And what we do is we mimic through the iOS headers and call over to the Java version for you, and then basically give you the same implementation that you would expect. So that way you can get your code running in a couple minutes, hopefully. And so when I say no compromise, you get everything that you get in iOS. You get Arc, you get C++11, you get assembly. You can write all the assembly you want to. We're not going to get in your way. You can use Objective-C literals. You can call every function in the Objective-C runtime. It all works. You can swizzle to your heart's content. You can hack away. It will all work. And this pretty much enables some of the more esoteric and hardcore iOS libraries just to work out of the box. There are some source code translation tools out there that would try to help you generate Java, and they pretty much fail when they get to this part. So basically you ship user-aligned implementation of iOS with your app, in a sense, 6 megabytes of dependencies, and you have an Android app. So this is our closet at the office. 600 devices that we have in there that we test on rigorously. So we buy the devices that are the most finicky and the ones that are easiest to develop on, and then that covers most of the Android market. Android, as much as people will tell you, is, they say it's not fragmented, it's very fragmented. But we do a lot in the platform to make sure that that's not exposed to you as much as possible. And then for some of the stuff that, once you get into our platform, how you can customize for Android, this pretty much pertains to building UI kit apps. Now, you don't have to build a UI kit app, but we actually expose all the Android SDK as Objective-C APIs. But if you're building for Android, what you can do is we actually have tools so you can continue to work in Xcode. We don't want you to leave Xcode because Xcode's pretty good. And you don't have to interrupt your own development cycle. And our goal is to continue developing the same way that you do today without stopping. And then you integrate our SDK into your continuous integration, and you're pumping out Android versions just as fast as you're pumping out iOS versions. And so what we do is we actually watch everything that you're doing inside of your Xcode project. And what we have is this thing called an AP proj. And it's essentially a diff of the things you want different for Android. So you can say, I want to add this file, and I want to remove that file, and then pretty much we just keep following your Xcode project. And I'll show you this in a minute. Supporting more screen resolutions, of course, there's more on iOS. If you use springs and struts, use auto layouts, all that stuff's going to work. If you don't, we actually have this thing that's a screen emulation mode. So if you did hard-code pixel values for 420 or whatever, you can actually scale up. It won't look the best. It's probably a good intermediate solution to ship now. But it's better to set this up and actually properly support the native resolutions. But until then, we actually have this nice emulation mode that will actually scale up your screen so that your UI screen matches the UI screen on the device. And then hardware button support, that's the bare minimum. If you're going to support Android, at least support the back button because your users will thank you. And we make it really easy. We just send it down the UI responder chain, and then you get this new event called UI button code back. And then you can do what you want. If you don't do anything, it X's the app. So it's a good idea to implement that. And then from there, we expose some ways to get access to the device information as well. We've extended UI device. This pretty much pertains to people that want to quickly ship an app with their existing code base. But we do offer solutions for people that want to build something where they're thinking about Android from day one. And then on top of that, we have this API. It's called BridgeKit. And this is what I was alluding to before. But this actually is a good portion of the Android SDK exposed as Objective-C classes. So you can see things like, good one is Android display. I can jump in there and you can see that basically we've exposed this object as something you can access in Objective-C. And so if you see, this actually inherits from this object called Java object, and this is part of our BridgeKit solution. What we do is we actually have this injection system where we've written in assembly this object system that will inject in with the Objective-C runtime methods from Java dynamically. So what you can do is you can subclass this object and you can implement all the methods that you want to for your object and pretty much get going right away with basically what the bridge kit does is it makes every Java object reference a Java object on the other side across the bridge, and then handles all memory-related issues, like it creates strong references into Java and then keeps it from garbage collecting until you've released it properly on your Objective-C side. So basically, we marshal these objects across. You can deal with them in Objective-C memory management concepts. When you're done with them, they get garbage collected. So it's kind of nice. And that way you don't have to write JNI, which is what we're trying to avoid, and so that you can deal with Android on Objective-C terms, which is really nice so that you can keep your code consistent and the same across the board. So on top of that, go back to the slides. So kind of covering what we do for, if you're using the UIKit app, how we bridge life cycles. Life cycles are going to be completely different on Android. Your app lives and dies at different kind of paces. So what we've done is we actually have this loose kind of wrapper, and this is not giving it justice, but basically application did finish launching comes from activity on create, did become active comes from on resume. It's kind of a loose correlation. But there's a little bit more going on back there because of like UI background tasks and everything else that goes on with the lifecycle of iOS. But push notification, local notifications, they're handled by Google Messaging or the cloud messaging if you're shipping a Kindle app. Then we also translate local notifications into a custom alarm service that runs on the device, so all of that works properly. In-app purchasing, we actually have full implementation of StoreKit for Google Play and for Amazon. So if you've already got that wired up, you can actually jump right into it and dump your products into both StoreKit implementations and start selling things pretty quickly. And then on top of that, so framework support. So you might be asking like how much coverage we've done. I can say the foundation, we have near full coverage. We actually have a brand new implementation that's been cooking for the last 3 months that has, we've completely rewritten our entire foundation on top of it. We originally based our foundation on GNU stuff, and now we've rewritten it from scratch. And what we've done was we actually wrote this thing called Foundation Tests. We open sourced it for all the other open source Objective-C runtimes to use so that we can all have better coverage. And we even have a good 200 tests that fail on apples that we filed radars for in the process because we go down to extreme detail of getting commonality between our two implementations. Basically anything that's not the same we treat as a bug, and that's how we move forward. Core Foundation is mostly apples. Apple open source is about 80% of their core foundation. We use the same code and then we implement what's missing. Core animation, it's a little limited, but we're actually building one that's completely backed by OpenGL. So if you're doing anything creative with core animation, we actually have that all implemented. And then UIKit, the shipping version's a little limited. So if you use the free version of our SDK, the stuff that we open source, it's a little rough because what we do is we translate every UIKit view into an Android view. And while simple, it does present some problems when you get into the nitty-gritty issues of how that translates. We do have a new full UIKit implementation coming that's actually backed by OpenGL on top of our new core animation. But it's more for people that are building apps that they don't care about it not looking like the operating system because maybe they're bringing their own experience anyways. They're just kind of using UIKit as a sprite system or something, or they're completely theming it and it'll look fine on Android as well. So for those people that need animations to be perfect, we have that coming. And I'll show you a video of what that looks like here in a second. So core data, we actually have a working implementation. It's complete in the sense that every feature's there. It is not nearly as performant. We wanted to get feature complete before we started optimizing, and we've achieved feature complete, but we have not optimized. So there is some other little limitations. You can't do manual migrations yet. We have a customer that's paying us to do that right now, so that'll roll its way into our main product later. AV Foundation, we have audio but no video support. This is mostly kind of a limitation on Android, and you have to pay for codecs, so that's the current situation. And then media player, video and audio supported, and OpenGL and OpenAL we have excellent support for. In fact, our OpenAL, we actually have this project we open source that is a complete integer math only OpenAL. Most OpenALs are written in floating point math, which doesn't run very fast on ARM, so we completely re-implemented it in fixed point math and open source that. And now EA and a bunch of other big gaming companies use our open source implementation of OpenAL on all their mobile apps. Top of that, so iOS 7 features, we actually have this in development. We have the Sprite Kit. We actually are 20% faster than Sprite Kit on iOS, even on iOS. So if you drop in our SpriteKit.framework, we don't know what Apple's doing. It blows our mind. Then we have full game controller API. So if you're using the new game controller APIs in iOS 7, your games will actually work out of the box on all Android controllers, as well as the Ouya's and all the Android-based gaming consoles out there, without changing a single line of code. And then on top of that, so this is a little preview of, it's a little old preview. I think this is about 2 months old of where we were at on our new UI kit. So this is actually completely OpenGL based and runs completely with our new core foundation. So this is all completely rendered in OpenGL. This is a couple months ago, so back buttons don't look right, and it still has an iOS 6 kind of theme. We've decided to go straight to iOS 7 kind of theme in the last month. But this shows how this is a sample app actually from Apple without a single line of code change and running the same exact code. There's another video where it shows the timing is identical, implicit transactions, implicit animations work exactly the same. That's the level of accuracy that we try to get to so that your apps don't have to change and hopefully there's no bugs, even if you're depending on some implementation details as well. And so, CocoaStudio. So this is going to lead into what I'm going to talk about in a second. What we've done is CocoaStudio, there's a little history to it, was originally, there was the original CocoaStudio, which was written in Python. Then there was CocoaStudio iPhone, which came out, was completely rewritten in Objective-C. Was done by a man named Rick, who got bought by Zynga. Zynga took over his project. He still maintains it, but then after he got into Zynga, he was developing games for them. They came to him and said, well, we want to go cross-platform. And so his only vision for going cross-platform was to rewrite all of Cocoa C++. So out came the baby project, CocoaStudio X, which is the C++ implementation. And what happened is that CocoaStudio kind of got put in the backseat because he was implementing all the new features in CocoaStudio X. And it was lagging. So what we did is we came to him and we approached him and said, hey, can we take over this project for you because we have a vested interest in Objective-C. And so that's what we did. We took over the project. We paid for all the open source developers to continue maintaining this project because a good number of our customers use it. We prefer Objective-C to C++, so we want to make sure this project lives. And then what we also did is we also want to improve the situation because now we have to go up against Sprite Kit. And Sprite Kit's out, but CocoaStudio is still more powerful version of Sprite Kit in a lot of ways. This is the way we see it. It's a little rough around the edges, but we think we can fix that, so that's what we've started doing now. The other thing that we've done is the Chipmunk Objective-C physics engine. We paid the developers of Chipmunk to release their pro version as free, so that that now is included within CocoaStudio. So what we're trying to do is actually make CocoaStudio be the premier game engine for the refugees from the Sprite Kit world after they realize you can't change anything and you can't tweak anything, and give you a transition path. And then we also sponsor the Cocos 3D project as well, because what we see is we see value in all these projects. They help the iOS community a lot, and so we want to put a lot back into those. And then as part of that, what I want to do is actually jump into showing you a new project that we created called Sprite Builder. And if you've ever used Cocos Builder, it's kind of the new evolution of Cocos Builder. So let me jump into that. So this is kind of a lightning talk that I've done in the past, but I just want to kind of run through it real quick. So blah, blah, blah about our company again. You already know how big Android is in the market right now. Not really going to go through all that. Yeah, no. Okay, Sprite Builder. A graphical interface builder and game engine to rapidly build cross-platform Objective-C games. So that's what Sprite Builder basically is. It's an IDE of sorts that helps you build for games, essentially. If you've ever used Flash, it has very similar concepts. So you can create your scenes and your animations and wire up your code, your physics bodies, all within this one UI. Then you go back to Xcode and wire in all the code. Kind of the same way that Interface Builder interacts with UIKit. Cocos Builder interacts with Cocos Scenes. And so it's very similar, except for it helps you build games. It's free, or it's a free open source project. We made sure of that when we forked the projects. Cocos Builder is still going to live on, but Cocos Builder has a different mission. They're trying to support all the baby Cocoses as well, including like Cocos City Java, Cocos City Lua, Cocos City Python. What we wanted with Sprite Builder is to make something that doubly focused on Objective-C developers. So we wanted to make sure that it knows how to knows what code you have in the project and can work with it more one-on-one without having to go with high-level abstractions and be more convenient. So we put a lot of effort there. So these games actually, a lot of these are our customers that we've shipped with. We've actually completely moved over to our implementation internally that we've given them the open beta to. And now they're shipping with our Sprite Builder instead of Cocos Builder now. And okay, so let's just build something. So what I wanted to do is kind of cover how we can make Angry Birds in 10 minutes. So I've never done this in front of people before. And so this is going to be kind of new for me a little bit too. So I've already set up a project just out of the sake of time. And the way this works is this is an internal build of Cocos Builder, so forgive any missing labels on things like it just says butt and butt and butt everywhere. So many butts. So what I've done is actually I've set up the scene, and I've just dropped in the assets. There's not really much going on. There's a scene in here which is just kind of the main scene, which just kind of shows the phone in all its glory. With embedded into it is just a single scroll view, and then it's just pointing to another CCB to power the content. And then this is like our game scene essentially. And this is where all of our code for our Angry Birds clone is going to be in. So what I'm going to do is I'm actually just going to jump straight into dropping things into this world. So for an Angry Birds clone, we need ground. And we need, well, before I do a ground, I need to add a physics node. So because we've integrated Chipmunk, physics is actually really simple. It's the first citizen in our new game world. So I've dropped in this physics node, and it's just going to be the top level node for our physics world. And then I'm going to put the ground inside of that physics node. So that's now going to live right there in the middle. And in this build, you can't resize. Oh well. Okay, so that looks about right. So what I'm going to do is on this third tab, I'm going to enable physics on it. And I'm going to say that this is a static. It has no dynamic properties. It's not affected by gravity, and it's not affected by any other friction or bounce coefficient or whatever. So it's now a static element in my physics world. And then I'm going to drop in, let's say, inside my physics body. Drop in other objects. Put something else in here, I guess. There we go. Okay, so we've got a few things in our physics world, and I'm going to enable physics on each one of these and give them dynamic properties. And the physics dynamic properties. I'm going to leave friction and density and everything else by default. It's usually pretty good by default. I'm going to enable physics on these guys as well. And then the other thing I need to do is I need to put gravity on this world. So in here, I can actually change the gravity amount. So I'm just going to say this is like -100 and pull the gravity straight down on this physics world. So I'm going to go ahead and just save that. Ooh, I have some nodes. This is a very beta build of this version, so give me a second to redo this. Publish. Cool. So I'm going to switch back over to Xcode. and I'm going to go ahead and just run this and see what our physics world looks like right now. Alright, now it's actually a little bit off the screen, but you can see it. It's doing things. Just rolled off the edge there. Okay, cool. Let's switch back, and then I'm going to just move these objects more towards the center so we can see them in a second. Kind of stack them a little, I guess. Save, publish, just give it a quick run, see what it looks like really quickly. There we go. Oh, don't fall. Alright, we'll fix that later. Alright, cool. So now we have physics. That easy. And I've actually not written a single line of code so far to do any of that. By default, what happens is when you go into SpriteBuilder, if you go to the new project, it'll actually generate you an Xcode project that will it will link in Cocos CD plus all the CCB reader stuff. Everything is in there. And if you have your initial assets, they're also copied into the project file as well. So it makes it really fast to get something up and running. Although you don't have to do any of that. You can actually do it the other way. You can create your CCBs and then include them in an Xcode project if you want to. Now that we have that, let's go ahead and we need a button to actually launch our birds with. So I'm going to go ahead and use the tower button here. But actually, I'm going to make this a button. So I'm going to drop in a button. Alright, there's a button. I don't want it to say button. I want it to be blank, and I want to use this sprite that I've already got for this button. And I'm going to set that to null because I don't want a highlighted image. And there we go. And let's just give it the right height and dimensions. And I just know because I know that that's 125 by 100. Alright, so now we have a nice button. And now we need this button to do something. So we need to wire this up to code. So what I'm going to do is this entire CC node. What I'm going to do is actually I'm going to make this a custom subclass of a CC node, not a base class. And let's just call this like game level. All right, so now we have a game level. What it'll do is kind of like a nib. It will try to inflate the class game level and load it. Then I need to assign this button to call a selector. So I'm going to call this like launch bird. I'm going to set the target as a document root. And the document root is the root node. In this case, it's the game level, and so that's where the code will be. All right, so now we have that. Let's jump straight into code and create a brand new class, a new CC node. So if you've ever done Cocos, this is probably natural to you. If you haven't, it's pretty straightforward. Online, there's a couple of easy tutorials that will get you up and running with Cocos pretty fast. But in this case, I'm just going to create a new CC node, call it game level, drop it in, stick it in my source. All right, cool. Now we have a nice new game level. So I always do this because I have a standard of how I like my code. All right, so let's go ahead and add our selector or our method that's actually going to be called for this launch bird. Send ID sender -log bird flies. All right, cool. So if I run that, oh wait, let me make sure I've saved and published first. All right. So if I run that, hopefully, if nothing went wrong, when I click this, we should see it print. Yep, bird flies. All right, so code is wired up and doing things. All right, so now that we have that, now let's actually make a bird fly. So we need to shoot this out of something, and thankfully I've already thought ahead, made an asset to shoot this thing out of. This is my new cannon, and so what I'm going to do is I need to pivot this around another anchor point. So I'm going to just move the anchor point up to the bottom. That's good enough. And then I'm going to stick move that guy out of the physics. And put the arrow just above the button. All right. That makes me happy. I'm a little picky. All right, so I made the timeline earlier 2 seconds. So what I'm going to do is, if you ever use Flash, this will look a little similar. I'm going to create an animation tween. And the way I do that is I've got the item that I want to animate selected. So what I can do is I can go up here and insert a keyframe. So first thing I'm going to do is I'm going to select on the timeline where I want this thing to occur. And I'm going to go ahead and insert keyframe rotation because I want it to rotate back and forth a little bit. So after, this is the default, and so I'll go to 1 second. And at 1 second, I'm going to go ahead and insert another keyframe. I'm just going to press R, a shortcut. And then I'm going to rotate this guy, let's say, I think 70? Let's do 80. Yeah, 80 looks good. And then we need to put it back after the end of the second. So I'm going to move this to 2 seconds, insert another keyframe, rotate that back to 0. So if I now go back to 1 here, and I play this, just get a nice little animation going. Cool. And the other thing I want to do is I want to put this on the default timeline, so I'm just going to go ahead and select that, because there's a secret bug. I don't tell anyone, but that doesn't actually do it by default. Alright, so publish that, and switch back. Let's just see if that runs real quickly and see if it continues animating. Awesome. Alright, so now we have our animated cannons. Alright, so now let's make this cannon do something. So the first thing we need to do is we need to get the rotation of the cannon. But we don't have access to it because we don't have it wired up to anything. So the first thing that we actually have to do in SpriteBuilder is we need to make this exposed to our code. So what I'm going to do is in here, I'm going to assign this to an IVAR. And this kind of works the same way that Interface Builder wires up your IV outlets. I'm going to make this inflate to say that this is the launcher, underscore launcher. And go ahead and publish that. Actually, I need to do one more thing too. I need to go to the physics node, because what I'm going to have to do is put the birds in the physics world. I need to launch these things and they have to fit within the physics world. So I need something that gives me access to the physics layer. So I'm going to assign this to phys layer, I guess. Sounds good to me. Alright, so now that's going to wire up 2 separate IVARs for me. I'll jump back to my code here. And let's just go ahead and say cc physics node phys layer and cc node launcher. Alright, so that'll do all the automatic work of wiring all this stuff for me, and I won't have to do anything past just putting an IVAR there. So now we have the launcher. We can figure out the current rotation at the time the button is pressed just by calling rotation. The problem that we get with this is that this is done in degrees. And in order for me to figure out the math for where to launch this thing, I need it in gradient or in radians. So we actually have a nice convenience macro that just converts my degrees to radians. Let's just go ahead and stick this in a float for the rotation. All right, so now we know the rotation, and now we got to do the math to figure out the direction of where we need to fly this thing to. So I'm going to say CG point direction. Let's see if I can remember this off the top of my CCP, this is basically a CG point create. It's a shorthand macro that Cocos uses. Sine F of rotation and cosine F of rotation. Ooh, that's right. Okay. So now that we have a direction that we need this thing to go, we need a bird. We need to actually create a bird. So in our CCB document, we've actually already have a bird document. So what we can do is I can say cc node equal, and just like with if I called a UI nib or a nib loader, we have another concept. It's the CCB reader, and I can say node graph from file, and I'm just going to say bird, and now I have a brand new node that's our bird. So then I'm going to say we need to add this bird to our physics world. It has to exist within our physics. So I already have access to the physics layer. I'm just going to add child of that node. And then this bird has to exist somewhere. So let's give him a position of, it's a good position, probably right on the launcher. Actually, I need to put him up a little higher than the launcher. So let's just do CPP add, which is just for the current position, add this amount. And then I'm going to do CCP multiply of the direction CG point that we've already created. And I'm going to just say 50 and just give it a little height. So that's just going to move it a little higher than the launcher a little bit. All right. So now we need to make our node move forward. So I'm going to say node.physicsBody, apply force, CG multiply of the direction, and we got to give it a good velocity. Let's just try something big first. How many zeros are there? Okay, that's good. All right, that should be it. Okay, so what we've done is we've got the rotation. We, from the rotation, derive a direction, and then we load a bird. We add it to the physics layer. We set its initial position, and then we tell it fly. And hopefully, let's see if this thing works. Ooh, build. Okay. Oh, there's a bird. Awesome. There we go. Okay, so there, in a couple of minutes, is how you can build Angry Birds really quickly. I've only written that much code. That's it. That's my Angry Birds. I did the rest in Builder, wired it up everywhere. So what we've done is Builder is a completely open source tool. You can, if there's a feature you want, you can fork it, add it to it. We have quite a number of customers that are just doing that. They've sent us tons of features, and we're improving SpriteBuilder out as we move along. But this entire tool, we're trying to build an enterprise class animation studio that basically you can give this to your designers or your developers. They can work closer together because your designers can use this tool as well. They don't need Xcode, and they can pretty much drag and drop and then set up the world the way that they want it, and then your developers can wire up into it and get using it. And hopefully, with just that much and with all the changes that we put into Cocos, trying to make it a fully fledged game development environment so that people can publish games quickly and iterate quickly. And we hope that provides some value. Anyways, so now let's make this work on Android, which is the next fun part. So I've got this already set up. Let's just switch over. So the Portable SDK, it's pretty easy to get set up. What you can do is you can go to apportable.com and download the free SDK. You just press the big button on the website, basically. So what that does is it puts a portable tool in your command line. And it's pretty much, if you've ever used Rails, it's kind of the center of the world. It generates your projects, all your scaffolding, it generates, it builds your stuff, it debugs it, deploys it, does everything. So from the Apportable command, basically you can build for Android. It works next to your Xcode project, so I've already got an Xcode project right here. I've already ran this tool once, so it generated the AP proj, but if you run it once, it will actually do this for you. And if I show you what that looks like in here, there's well, way more files than I thought would be in that tree. Let's do this. Tree. All right. So what this does is it generates this folder structure next to your Xcode project, and essentially what's in there is a configuration JSON plus a couple of JSONs that you can use to override how you want your Android build to work. And it's pretty straightforward. It's self-documenting JSON code. So this is what the format looks like. So there's it's basically a big JSON file with a configuration section, an add params, and a remove param section. So config lets you change like the application name you want on Android, lets you say like Android has permissions. This is where you can put the permissions for what you need to, your app is going to need on Android. Any kind of URL schemas, any icons, anything you want to override about your Xcode project, you can do in here. And then for actual code, we have this add params and root params. So in here, you can say, well, don't build this file, but build this one instead on Android, or apply this flag, or turn this define on. By default, we have two defines turned on. One's a portable and one's Android. So you can put if-def Android, if-def portable, and that code path will be hit for Android. And it won't happen for your iOS build. So you can keep your code identical except for the bits and pieces that you want to keep separate. And in here, you can put things in here like additional assets. Maybe you want to use completely different assets on Android. It's all configurable in here. In this case, I'm not going to change anything because the default configuration is good enough. So I'm just going to go ahead and run, in this case, a portable load. And what that does is it runs my Xcode project to figure out how we build it for iOS. And then it learns from it, and then it builds it for Android instead. And so what it's doing now is it's running through our entire Xcode project that we built before. It tries to do a differential as much as possible, but it gets limited in some ways, so it does have to rebuild some stuff. This is why we also advocate it's probably better to keep developing in iOS as you're developing for Android because you'll have a faster debug cycle. But it's not too bad. So I'm going to go ahead and just plug in this device because this won't take very long. So now it's figured out what needs to be built. Now it's building all the targets. There we go. Now it's packing assets. And there we go. So now it's, what it does is it dexes, there's a small amount of Java that just launches the application. And then once the application's launched, it's everything that you need is jumps directly into native code, and then your entire app runs natively. But there's a small shim that just launches just to get the app launched. And so this part runs the dex compiler. And now it should be packaging the APK. So on iOS we have IPAs, on Android you have APKs. So now we should get an APK out of this. What you see also is it packaged all the libraries that were built out of this. So there's a libconfig and then there's a libverde, and libverde is actually where most of your code will live. Verde is a pun on the original iOS project being called libpurple. So we're libgreen. So now it's packaging things that you might notice, libv, libc++, libsystem, libobc, libdispatch, libfoundation, all the stuff that you would find from iOS. And all that gets packaged into the APK. And now it's signing. So the more you do this with a project, the faster it gets because there's caching and incremental linking that happens as well. So your development times will increase the more that you build for Android. Now it's just waiting on a device, and hopefully this USB cable is not awful. It feels awful. So you can use the Android emulator that comes from Google. It's really, really, really slow. All right, so there we go. Oh, there we go. So it's up and running. Hopefully, yeah, there it goes. It's actually working. So no code modifications. This runs completely on Android. It's all Objective-C. No changes from the iOS version. Eventually my birds fall. And this is actually a debug build, so the frame rates will be a little better, although this is a very hefty device, so it's getting 60 frames right now in a debug build. But typically your cheaper Android devices, your 2-year-olds, will need a release build to be even usable. But that kind of shows Apportable in a lot of ways, hopefully. Basically it runs, it gets the same default icon from iOS. You probably want to put a better icon for Android, but from there I could almost ship this as fast as I shipped it on iOS, hopefully without changing anything. But anyways, that's a big part of it. So Apportable, we kind of want to be thought of as the new Objective-C company, so the same way that Xamarin is the C# company. They didn't invent it, but they promote putting it on everything else. We think of ourselves as the Objective-C company. We want it running on everything. So although everything I've showed you today was Android, we never wrote any of our technology to be specific to Android. So eventually, if you stick with Objective-C, you'll be able to go to BlackBerry and Windows Phone and everywhere else using our platform. Although our focus right now is Android because that's where most of the money is. So that's most of what I have. More about me. You might have seen me on in Wired magazine, Business Insider. I was on DWDD a little while ago with this special about Silicon Valley, Alex Extra Coupling's special. I was in the second episode, the Hackathon Junkie. But that's my Twitter, and that's what I have. Thank you.